Sounds test. 1, 2, 3, 4. Welcome everybody. We'll do harder problems today. We should be live on YouTube and Twitch. We should be live on YouTube and Twitch. I will finish solving the cut forces around 1035. Mainly those two problems. This will be a quick warm-up. Hello, Om and PKG. God Gamer, hi. I will finish solving the cut for. YouTube should be muted, otherwise there is echo. I look old. I guess I'm not that young anymore. Tomorrow, same time, there will be easier stream. So today we're doing hard problems, and tomorrow something easy. I don't know yet what exactly. I'm from Poland. Hi, Nathan. I still didn't upload the CSCS tasks to GitHub. Let me write it down in the calendar that I want to do it today. Okay, noted. I'm using Ubuntu. A video on game theory, maybe one day. As always, today I will talk a little bit about what I currently think about my streams and just how I should spend time on doing this educational stuff. Okay, so this will be a warm-up. I actually already have read this problem and the next one, so I know how to solve it. I will not spend too much time on it. You're given 4 positive integers. Here's the problem link. Link. After this one, we have E and F remaining. Videos on algorithms. I mean, I'm covering algorithms. Not usually recently during streams, not videos. Can you become GM one day on Code Forces? I have no idea. But it's unlikely. Not many people become Grandmasters. CP course update. What I have is classes on dynamic programming next week. So should be somewhere here. Yeah. If you're interested in classes on dynamic programming, there is one easy group, one hard, then this is the link. You can read about it. €250 per a month of classes. Okay, good problem. You're given NL RK RK. You need to find the lexicographically smallest. So we minimize the first element, then second element, and so on. Array, such that the length is n. Every value AI is from L to R, and bitwise AND is equal to bitwise XOR, which in particular the parity here is very important. If no such array exists, output -1. In particular, if well, let's read the stuff. There is n can be up to 10 to 18th, but we don't output the full array, we only output the kth element. The array may be too large, output AK only. So we are not constructing the full array, we are focusing on one element, kth element. But in particular, what's the order? N, L, I will call this low, high, and K. If n modulo 2 is 1, so if length is odd, then all elements can be just the same, and then this will be satisfied. Bitwise AND, for example, 7 and 7 and 7 is equal to 7 XOR 7 XOR 7. And this is true for any element, not just 7. Can you please turn on auto caption? Thank you. I don't think that's possible, at least not so easily, during streams. I wonder if there are some tools where you as a viewer can turn auto caption on your own, like some kind of browser extension. Okay, if this, then simply we can output low, because all the elements will be equal to that. And otherwise, when n is even, and you want to satisfy this is a little bit more tricky. Every bit, so that this would be true, every bit needs to appear exactly odd number of times. Let's see an example maybe. Let's say that bitwise AND is equal to something like this. And now for XOR to be this, you can have few elements equal to that. In general, this is the smallest that you can use. And then what? Well, if I use here a 1, right now the XOR of those values, of those bits at this position is indeed 1. Here I need to use a 0, because otherwise the XOR would be 1 right now, unless I had another element. If I had here another element, maybe like this, then here I could use 1. So what do I do with that? Let's first observe that we need to find lexicographically smallest sequence, and for that as many elements as possible should be equal to that lower bound, the L. So in particular, if this is, let's say, the low, or L, then we try to make a lot of elements equal to that, and with just the last few elements we will try to fix the XOR value. And now I will basically experiment on that. N is even, so for example, right now n is 4. I cannot, just by modifying the last element, I cannot achieve that. For example, if n is 4, if those are the 3 elements, then the last element would need to be 0 for those to XOR back to the same value. And then, well, then the bitwise AND will be messed up. Yeah, but if anywhere there is a 1, then again XOR and bitwise AND will not agree. So yeah, there is no way to just modify one element. That being said, I claim that first n minus 2 values should be equal to low, to the value L from the statement. Stuck on 12 rated problems, what should I do? Solve 1100 rated problems, I think. Munib. And here, let's see. One of those values should be, one of those two elements should be 1, the other 0. No, but then the bitwise AND will not agree. So both should be 0. but that's impossible. So maybe it should look like this. The last two elements should have a 1 on some big position. Then on this position we want bitwise AND to be equal to bitwise XOR. How can we achieve that? If I do this, then XOR is 0 of those 4 ones. If you have 4 ones, bitwise XOR is 0, bitwise AND is 1. So it doesn't work. If I do this, then AND is 0, XOR is 1. If I do this, then it works. So if there is 1, 1, then I can have 0, 0. Then it seems zeros, zeros, and so on. So this seems reasonable. Now, is it enough? I'm not sure. I said that I've read this problem before, but I don't know a full solution. So my current idea is that n-2 values must be equal to low, and then the remaining 2 values should be equal to the next power of 2. Unless that doesn't exist, then the answer is -1. Let's create some power variable, call it E. I want to say that this is greater than low. Well, this 2 at power E is smaller equal than low, E++. If this is this power of 2, find next power of 2. If this is smaller equal high, then this is good. And if it's greater than high, then it doesn't fit in the allowed range, so I output -1. Otherwise, if k, the index that I'm interested in, is up to this, then it means that it's one of those values equal to low, so we output low. Else we output that power of 2. We'll see if it works on the sample test. Whoops, I here incorrectly do something. So just this one test doesn't work. It's this one, I think. It should be -1. So here n is 2. Oh, n is 2 might be a special case. Also n can be 1. That also might be a special case. Because here I assume that those values exist. Does it change anything? Okay, let's think. N equals 1 is easily handled by that. So I think it's just about n equal to 2. N equal to 2. Bitwise AND needs to be equal to XOR. If those elements are the same, then this is equal to them, this is 0, so that doesn't work. If those elements are different, then at some position they differ, and this will end down to 0, and this will end up to 1, XOR down up to 1. So I think that we should output -1. I think it's always -1. If n equals 2 or this. I don't think that n equals 2 is solvable. Works for the sample test. What is it? A good problem? Good problem. I see some long comments in the chat. With definition of bitwise XOR, I don't need those long copy-pasted information about XOR. If somebody doesn't know what XOR or bitwise AND is, then they will not solve this problem or understand the solution in 5 minutes. Okay, warm-up done. Now we move to two real problems. And constraint. And then after that it will be volcanic eruptions. So again, some bitwise operations. Do we have test cases? Yes, we do. Oh, one more thing. If you ever later watch recording of my stream and you want to see my code, you want to maybe copy paste it, use in some way, what you should do to achieve that. So I don't need to actually upload anything to GitHub repository if we're talking about code versus submissions, because you can go to my profile, hit submissions. I think it's also visible from incognito mode. Let me make sure. Yes. And you should scroll to the date of the stream. In particular, the date very often you will see at the top of my screen, like today is July 15. And if you, for example, need something from 28th of June, you scroll down to 28th of June, and here apparently I solved this problem, jellyfish and something. And if you click here at the ID of the submission, hello? You cannot see it. Only people with some special access can see codes of others? What? If you're not a trusted user or you're not logged in, you cannot open it, but it's a blue number. I mean, it's a link. It doesn't work if you haven't participated in the contest. Interesting. Oops. Okay, well, then at least you need an account. Not sure. Well, let me open somebody else's account to see how that works for me. I also cannot click that, really? Status. Or maybe something is broken. Not allowed to view the requested page. That cannot be right. Maybe you can paste the code into something like paste Ubuntu. I wanted to say that I don't need to do it. Oh, I'm still in incognito. Okay, sorry, I'm stupid. Now I want to see if I thought that I closed it and now I'm in my normal browser. No, I want to see somebody's submission. Okay, it opens normally. In Gym, do I have special rights right now? Disable coach mode. So now I should be a normal user, just like any user. And it still opens. Okay, good. Then I stand by what I said. Usually, if you want to get my code, my submission in code forces, you should scroll to the date of the stream and then find the submission. Okay, end constraint. You're given a sequence A of length n minus 1 and a sequence B of length n. You can increment element of B by 1. Use the minimum number of operations, and you are given bitwise AND between two consecutive values for every two values. We need to output the number of operations. I don't know if I've already pasted the problem link, but here it is. So we might be given information that b of 1 and b of 0 and b of 1 is equal to something, is equal to, let's say, this. Then b of 1 and b of 2 also is equal something, let's say this. And what do we do with that? From that, I think we can roughly get the value of b1, because this means both b1 and b2 have those bits on. This means the same. Well, let's think about it this way. For the information that this is bitwise AND, it means at least that those bits are on in both numbers. So b1 needs to have those bits, b1 also needs to have those bits. So if I compute bitwise OR of those two, this is, I think, a of 0 or a of 1. If I compute that, so put a 1 whenever there is at least one 1. So this is information about necessary bits of b1. Now, this position can be a 1, but we need to be careful. We cannot break those conditions. The zeros mean that at least one of the two numbers need to have a 0. So preferably we should use a 0 somewhere. 1 is only used when needed. We are given some initial values of b. We need to increase it by 1 as many times as needed. So if those bits are needed in b1, and initial value of b1 is something, let's say this is initial b1, then at least what we need to do is raise this up to that value, and then maybe do something extra. This is greater than that, so I just increase until it's equal. So at least increase to the required value. I also have an idea that for safety we will assume that just at the beginning and at the end of the sequence B there is an extra 0, and also then its bitwise AND with neighbors is 0. Maybe that will help. Yeah, Arc, I'm timing you out. Stop repeating stuff. I don't know how you imagine answer to your question anyway. So we increase to the required value. What if this is already greater than the required value? Then I think we will add an extra bit 1 at the beginning. Right? So if this is required, and let's say this is what we have, no, then we actually do nothing. This one is already here. Okay. But then we cannot have too many ones, because it might break a condition where every 0 in the input in bitwise AND between two neighbors, it means that at least one of the two values, bi plus 1, cannot have a bit here. I don't think that's true, but maybe it's true that every bi is either its initial value or the required value. Exactly that. I think it's incorrect, but maybe. So from the required bits we have something. Maybe we need to increase bi to this, or maybe bi stays as it is. Actually, it might be a combination of that. For example, if, let's see, this is required and this is initial value. Now we increase the initial value up so it would include those. then we will have this. Initial value increased to contain the necessary bits. And that should be easy to do, to increase the initial value as needed. It might lose some bits, of course, like if this is required and this is what we have initial, then by increasing this to contain those bits, we will get rid of this. This will become 0. Now, after we increase the initial value to what is required, I think we should forget about the initial value. We just have something current that has the necessary bits on, and I have such a sequence bi. Now I need to turn off some of the bits, still preserving the bits that are required. So let's say that somebody tells me that here in this position I need to turn this bit off. For example, here maybe somebody tells me this bit needs to be off, but I can only increase. So if I want this off, then I need to increase. In this case, it means I will put an extra one here. It's a necessary one, so also it can cause some harm by bitwise ending with the next value. Generally, I prefer zeros unless one is needed. And then in the remaining part, I can have whatever I want. So for that, I will put only the required bits. Let's also make a drawing. Maybe it will help. I increased bi a little bit, and after that it is equal to something where some of the ones might be required. Then this one, the remaining ones, they are not required. So I will say whatever, though 0 preferred, because if one is not required, then you between two consecutive values bi, you need at least one of them to have a 0. So it's always nicer to already satisfy this here, not count on your neighbor. And you can say the same thing about the remaining elements. Plus, you can get information that maybe after you already are done with the previous element, bi minus 1, here you might need to turn off some elements. Maybe this needs to be off. Maybe this needs to be off. How do you achieve that? The next thing that can be on, you turn on. So among this is also a 0 here, infinite number of zeros on the left. So I'm going from those required off positions, the next 0 on the left, which is in this case here, this one turn into a 1. And then on the right, because already this makes sense or guarantees that I'm here increasing the value. So all the unnecessary ones, I can turn immediately into a 0. So this changes into 0. This, well, it was 0, but it again changes into 0. From that, I would say that always what we will have is the value bi, where somewhere I make a decision to change 0 into 1. Then after that, this suffix is easy because in the suffix, wherever there are necessary ones, the ones that I said they are required, I said that in green earlier, required, and everything else is a 0. non-required ones become 0, because thanks to me increasing that, I can afford whatever I want here, and zeros are preferred because they make it easier to satisfy the 0 conditions with neighbors. Regarding the prefix here, is it's whatever the initial value implied. Whatever the initial value implied. By that I mean we are given bi and we first increase it like I described in the editor here, that there's some information that this needs to be a 1, this needs to be 1, so we raise up to that amount. We will change, and now it's not that we go from left to right and we do things greedily, at least I don't see why it would work, because it's hard to make a decision about the first element if you don't know the final state of the second element. But if the state can be described by which bit you turn unnecessarily from 0 to 1, and then it implies everything else, this will be the DP state. I will have DP of n by 30 or 60. 30 is enough. DP of n by 30, int or long, or what is DP of I by k? Minimum in total increase so far. If we change bi into value where kth bit is unnecessarily on. Yep. Everything after that is as required, everything before that is as implied by the input. So that we greedily increased from the input value bi to satisfy the conditions about ones with neighbors. So for every value in the input, you have only 30 possible candidates for what it will become. I think that's nice, a nice way to put it. And this will be minimum score so far, or total number of increases, if the ith element we change into its kth possibility. So we will do maybe 2 separate phases. In first phase, for every element I will find 30 or 31 candidates for what it becomes. For every candidate it's trivial to know how much I should increase up to it. And then as I do the DP from left to right, always if I know what the previous element became, then and I iterate what the next element will become, I can easily check with bitwise AND if the needed condition is satisfied. So I'm aiming at n times log squared, where this is logarithm of 10 to the power 9. Can we quickly recap everything before the DP? Yeah, I think now I will recap before I code. Maybe using the example. I'm not sure if first example is strong. Maybe I should use this. A first example has 4. That's fine. Okay, let's explain again using the first example. Those are values between neighbors. Now, for every element, like this element 2, I know that I have some requirements about its value bitwise AND with neighbors. If there is a 1 here, it means that in particular this value needs to have a 1. If there is a 4 here, then this value needs to have a 4. So at least what this element needs to become is a 5. Because it needs to have all the bits of this guy and all the bits of that one. Otherwise, those values wouldn't possibly become 1 and 4 when you compute bitwise AND between neighbors. By the way, bitwise AND is similar to minimum operation, just in multiple dimensions, because binary string is kind of like a point in multiple dimensions, by the way. Is this, and what I'm doing is, if I get information that minimum of B2 and B3 is equal to 5, minimum of B3 and B4 is equal to 7, then this implies something about B3. B3 here would need to be increased at least to a 3, and sorry, at least to a 5 and at least to a 7. So here at least to a 7. So I would say B3 becomes maximum of its original value, the one in the input, and also, well, A of 2, A of 3. In our code here, I will say that a B of I becomes maximum of itself, and A of I minus 1 or A of I. This OR is like maximum here because it says I need bits from here and from there. That's the implied value of BI. At least I need to raise to this level. And then I can modify this a little bit because there are extra conditions about two consecutive values having enough zeros in the bitwise end. And for that, I figured that in BI, it's enough for me to find some position that I will turn from 0 into 1. Everything after that is trivial to determine, because we will put a 1 only where it's really necessary, because it was in bitwise OR of AI, A minus 1. In this prefix, I leave whatever I found is implied. Yes, you can say that thing about submasks. Yeah. And we have integers only, ints I mean. Now I wonder, should I add extra zeros? No, the 0 would hurt, right? Maybe not. I think we will do this. Now, B of 0, I have a condition now that A of I is equal B of I minus 1 and B of I. This changes the indexing a little bit compared to that. But I think now, so B of I is, or maybe affects values A of I and A of I plus 1. I just imagine that there is an extra 0 at the beginning and at the end, and I think it should work. We first read values A. Values A of 0 and A of n are both equal to 0. Then read BI's. Now that more people are viewing the stream, let me ask you, for a problem like this one, where it's not trivial, and I cannot solve it, I cannot fully come up with a solution in like 2 minutes, would you prefer, yes, my name is Kamil, would you prefer that I know a solution in advance and explain it well and not struggle? So what do you prefer during a stream? Option 1, I know a solution to a hard problem in advance. Let's say I explain and code. And option 2, I do not know a solution. I try to solve it. Possibly I spent 1+ hour. It happened in the past, like recently in some hard AdCoder problem, well, not very hard, where I implemented BFS, thought that it doesn't work, implemented Dijkstra, it was too slow, I needed to optimize for half an hour, and then it turned out that the BFS would work, just a little bit simpler BFS. Most people prefer the 2. I mean, it's easier for me. The version 1 requires some preparation. But it is also the option 2 that you guys prefer apparently. It means that sometimes I will solve like 1 or 2 problems during a stream, especially if I'm doing hard problems. For example, yesterday, so before the stream today, I did read the problems E and F. And for both, because of that, already before a stream, I had some idea for a solution. Not a complete one, also I didn't implement anything. For F, I also took a look at the editorial, but my solution is slightly different and I'm not going to exactly follow the editorial. But yeah, I just wonder what is in some way better. The thing is that you make your solution work with complicated code implementation, never seen code optimizations. Chandu, can you explain more what you mean? So are you saying my code is complicated? So it's good, it's bad or good? So am I immediately implementing something fast or slow and then doing strange changes? There are just too many ways I can interpret your message. I agree with Mav08. It's hard to get epiphanies when you're not 100% focused. Obviously, outside of stream, I'm better at problem solving than during a stream. Of course, it's easier if you have prepared. I mean, easier is a tricky word. If I have prepared, then I spend time in advance. So I had the hard job earlier. I'm just wondering what you prefer. Part of the thrill and learning for us is your thinking process and what would you think about some solutions, how they turn out wrong. Oh, actually, if I think about something before a stream and it's incorrect, I can also talk about it during a stream. That's not a huge issue. And do you really need a thrill during such a stream, or do you want to learn? When I do lectures, when I cover some hard problems, I often go through an incorrect solution, especially if I think that it's reasonable to come up with it and try it. Why does the following greedy fail? Okay, but I see that you like this thing. I think then what I'm going to do is only if I want to, maybe let's say if I want to do a division 2 round, fully during a stream possibly, then I will in advance read the hardest problem. Why does the following greedy strategy fail? Increase BI until BI has all the bits in this. Because possibly 2 consecutive BIs will have some unnecessary bits. Right, so let's say, what about this? Let me create an example. AI I want to answer this thing. So I'm worried about a case where AI has only few bits on. AI plus 1 has only few bits on. And all the values B, let's say this is A1, this is A2. B of 1 is equal B of 2, is equal b of 3 is equal to a series of 1s. Yep, I think this works. Okay, this is your counter example for this question. Why is it not enough to just increase bi until it has all the bits necessary? Because this is an example where bi immediately has all the bits necessary. So that first part of making sure that the necessary bits are on, it might do nothing. Also, it might do something, but it will still have a lot of unnecessary ones. So right now, my b1 is equal to this, my b2 is equal to this, b3 is equal to this. But I want the first two to only have this 4th bit from the right on. How do I stop? Okay. So what we should do is here we should modify the values. I should change this. Maybe I will add an extra 0 here. I'm going to change this into a 1. So I'm increasing this a little bit. Then a lot of zeros, but 4th from the end needs to be a 1. Like this. Then second value and third value. This needs to have 5th from the right on. No. Yes. Let's do it like that. Like 2 more zeros skip and then this. Like that. I think now we're getting somewhere. So for those values b, indeed the bitwise end of those two at least will include this. For those two it will include that, but not correctly. We have the extra one at the beginning, and we can fix that by doing something like this, where also among those first few bits they are not all the same in all the numbers. Also, I'm not sure if maybe this is an example showing that we are operating in the input with 29 bits, but here I'm using 2 extra bits before that. So if the numbers in the input are 2 to the power 29 minus 1, maybe we need all 31 bits? I think I will use 31. Okay, so we have this. How do we increase until we have the necessary bits? Phase 1. Increase bi to include bits from this. Of course, I don't want to increase bi 1 by 1. It's not as simple as doing that either, because I can turn off some of the bits for free when increasing like that. For example, if bi is, let's say, this, and the also value is this, then I need to have a 1 here and there, and this automatically turns off those guys. So starting from the first bit that I'm increasing, everything after that I can just copy from also, starting from the big bits. Wait, here 28. Let's use 29. If also contains this bit, but bi doesn't, so I need to turn it on. This remaining suffix I should just copy from also, because the bits that are in bi are unnecessary. So from here on, copy the also. let's see. Get rid of the last that many bits, +1, because also this guy you want to get rid of. Then move it back. This changed the last that many bits into zeros, and now I want to take those bits from also, but I only want to extract the last part of it. Copy the last j+1 bits from also to bi. I think this is what I did, what I need to do. Then break, because you found that this find first bit, so largest bit where they differ, as in 0 and versus 1. Because if this is 1 then and this 0, I ignore. Okay. So I see where I need to increase. Let's also make an assert. Memo bi. This is the initial value. Wait, I shouldn't do this, right? Yeah, I shouldn't. At the end, I need to assert that b of I is greater or equal than the initial value. Because if I created something smaller, then that's very suspicious. And answer gets increased by the difference. No, wait, yes. This was just the first phase. Well, I hope that I never overshoot. Yeah, I never produce answer bigger than what the correct answer should be, so that's good. Because it would be strange if already in phase 1 I did all operations, more operations than what is necessary in total. Next, phase 2. What is phase 2? It's a DP, or maybe find roughly 30 candidates for every BI. That is, for every BI, I know the necessary bits, it's still this. I know the necessary bits, and I wonder which of the remaining bits I need to turn from 0 to 1 unnecessarily. Maybe it should be combined somehow here, because it's very similar code. Let's make it separate, though it is similar, and I'm sure that the code can be made way simpler. So you see, this is the case where if in advance I prepared, I would be able to explain a simpler solution, but I think I'm going into something too complicated, where I think the two phases can be done at once with almost the same code. While doing dp of ij, do we say that every bit smaller than j is 0 except the necessary bits? Yes. Yes. Candidates for n. I'm going to do the following. For every bi, this still applies. Those are the necessary bits. And in bi, those are on already. I can assert that bi and also is equal to also. Not sure if brackets necessary. Now for every position, And not sure about it, but from my example from before, I'm guessing that maybe 31 positions are necessary. I'm saying if BI right now doesn't have this bit, can I even compute that? For 30 I can. Okay. I wondered if we overflow maybe. If this bit is off, then maybe I turn it on. I have BI. This bit gets on. And then for all the following bits, I just copy them from also, which is what I did here. And I want to does it matter if this bit is in also? Oh, this means it cannot be in also. Assert not also and this. Because B is overset of also. Okay, so this is the candidate. And well, let me copy though. I'm not the fan of what I'm doing. We have this. I copied the bits, but also I want this extra guy, b of I, or equal candidate. Candidate is b of I. Maybe let's say here we add this extra element, and then only the last j bits we move like that. Then candidates of I push back candidate. I think those are candidates for what BI can become. In particular, it can also become itself. So let's add that possibility. So now we will have 32 cans of I. Phase 2, does IOI get streamed? Only the leaderboard. Many times in the past I did an official stream on IOI, just some commentary. No, I will not go to IOI. Isn't the Twitch stream name wrong? Let me see. What is it? Yes, it's very wrong. Sorry. And thank you for noticing. Also, I fixed my microphone. Let me tell you how stupid I was. Well, no, Windows is stupid, not me. This is code versus algorithms problem solving. Save. So I had that issue for the past several streams that people were saying the sound is too low. And indeed, it was quite low. I already in OBS set it to max. Plus, I even increased it artificially even more with some filter, which means that I decreased the quality of the sound. But yesterday I was playing around with the sound settings on in Windows. I scrolled down to the what? When did that change? How does that change? I'm so annoyed right now. So yesterday I was surprised that this volume input, this volume setting is set to 8, and I increased it up to 80. Then I could remove the filter in OBS and everything was anyway loud enough. Since yesterday I did something that caused it to move down to 20, but how? What? Why? Does it change when I restart the system? Is there some... Because there is output volume, which is here, whatever, that affects my speakers. I'm not using them much during the stream. And then there's this. So I claim it's still low, yeah, because it changed automatically from 80. So what I tested yesterday is that this will work well. I'm now speaking constantly. I'm speaking constantly in my normal volume. I'm not trying to shout. And now, I think now actually it's too high because I see it going into red in OBS. Now if I'm not close to the microphone, still, like, this is, not sure if this is distorted. Yeah, good. Too high. I can, maybe let's move it down a little bit. No, I did not change the microphone. I didn't unplug it. Crazy. Stupid Windows, but I do not understand. Let's do 70, yeah. After 2 hours of streaming, it matters a lot how loud I need it to be. It's hard to talk for 3 hours. It's a lot. I'm so annoyed, and yesterday I was so proud of myself for finding that setting, and angry at Windows at why I have a new system from like 3 months ago. This PC is from 3 months ago. I installed fresh Windows, and I never changed the input volume setting so much down. So annoying. Okay, I need to remember to test, I don't know, after restart of the system. Why don't you use Linux? Linux has its own disadvantages. Like, for example, I couldn't draw like this in OneNote. Okay. Now we have phase 3 will be some easier DP. I will say easy DP, because for every number we choose one of the at most 32 candidates, and we just check if between neighbors we satisfy the condition from the statement. The DP value should be how much we increased in total. So I will say initially for all the candidates. Let's look at B0. Look at B0. For every candidate of B0, DP pushback candidate minus B of I. This is by how much you need to increase. Also, assert that candidate is greater or equal BI. Yep. Then for every following element, I create new DP array. Also, I have two sizes. The previous candidate size to also DP size. Maybe let's use cans of I minus 1. This is not really necessary. New DP of size B. We minimize, right? Yeah, so by default it needs to be set to some kind of infinity. Let's use long max. Don't know about those characters. Divided by 2. I'm not a fan of using infinity equal to the max type of long or int, because if you add +1 to it, you already overflow. So I prefer this, or billion +5, or 10 to 18 +5. Now the interaction. For every possible element of the previous, so every possible previous candidate, let's make this into a variable. Infinity. 10 to 18 +5 should be enough. Those are candidates for BI and BI minus 1. So if candidates of I-1j bitwise and candidates of ik, if this is equal to a of what? A of, I think, I, right? Because I wrote it here. I-1 and I interact into I, yeah. If this, then this is good. So we do the transition, new dp of k, minimize dp of j, plus cost of transition is this candidate, kth candidate, minus the current value bi. Then dp becomes new dp, and answer plus equal the minimum element, right? Yeah, we minimize. dp begin, dp end. If it's at least infinity, and you see here already, if I used infinities, I would overflow. If this, then -1. Else. I not declared p of 0. Parentheses suggested. 4 minus 1, 2, 2, minus 1, 0, 5, 3, something, 1, 6 works. Time complexity n log log, so n log squared. After I get accepted, I will try to decrease this by 1 and to see if it still works. I'm curious. Yeah, I'm using a pen tablet. It's some very basic, cheapest possible Wacom drawing tablet. It's so it doesn't even have a screen. It's like a mouse. Okay, accepted with time of 1 second, so not so good, but not so bad either. I'm guessing that collecting the candidates. No, that's not bottleneck. This must be bottleneck. Well, and will it work if I do this? No, it already doesn't work for the sample test, so I don't even need to submit. Okay, problem solved with 3 phases. I will take a look at the tutorial now. Tutorial. First try. I mean, if the sample test is good, then, you know, is it unlikely to get accepted first try? Consider AI equals 0 first. I kind of consider that. Okay, BI must include the bits from 2 consecutive values A. There are 31 possible effective values for BE. Well, that wasn't easy for me to observe. I feel like there should be few extra sentences between those two. Like this is trivial, and then this is not trivial. Only 31 possible values for BI. I actually have 32, but whatever. Increase BI to above 2 at power 29. Submits to this. Here they prove that they don't need more than 31 bits. They are saying that every second element, if you look at things of length 31, then the input uses 29 bits. What you can do is every second element can start like this versus like that. So every even element starts with 1, 0, others with 0, 1. And then those remaining 29 bits you fill exactly with the value of AI-1 or AI. Though, instead of typing this in such a mysterious way, the editorial could just say that we can start with this solution and try to improve it. Now, we might consider which BI are more likely to be the answer. We should try to avoid having ones in each binary bit as much as possible. I agree. This will BI exhibit a stepped pattern. The preceding bits are the same as BI. Next bit is set to 1 and all subsequent to 0. Oh, and they also have log squared. I mean, well, the code is simpler, so maybe I should investigate how the code can be simplified. I'm not a fan of this editorial, but it seems that they are describing exactly the same thing. What is the rating of this problem? Does it have a rating? No rating yet. Okay, now to look at the code. Where do they start DP? F is the DP. Swap FG. Okay, F and G are DP functions. So they don't have 3 separate phases, they do everything at once, which is perfectly fine. I just unnecessarily 3 times go through the same array. So it's clear that I could simplify like that, but what else is there? They go bit, oh, I see. As they go through the bits, they keep collecting the big bits, and they already have it as X, the prefix, and they OR it with the needed values, so they don't need to do such binary tricks. For every J, I independently investigated. What if this bit I change from 0 to 1, the left part I take from here, the right part I take from there. Also, additionally, I think they observed that I copied the last J bits from also to BI. I can say that I take everything from also to BI. It needs to be there. So it's okay to this, sorry, don't see it well. Where I here have the candidate, I take some bits from also. No, I can take everything from also, because this is a requirement. This needs to be fully there. Same here, I think. So now I simplified a little bit. And does it still work? I think so. Let me submit again. Other than that, yeah, there isn't much else that I will change. I like the question from Ramsey. Let me try to answer that. If someone is, for example, solving division-free contests and can solve almost every contest till E, is it better to just solve the challenging problems EF or the whole contest? You're practicing a different skill when solving easy problems. You're practicing your speed and very simple tricks and techniques, which is fine if you feel like you need it. For example, for me, I'm very good at easy problems. When there is an important competition and it has some easy problems at the start, I'm one of the best. So at the beginning of the contest, sometimes I am winning because I'm faster than others on easy problems. I can read fast, I can just get few lines of code fast. So for me, if I want to practice more and become better, those problems are useless. If I wanted to now practice efficiently, I shouldn't even touch the easy problems, those where I spent 1 minute on it. On the other hand, the way I got here and the way I'm fast on easy problems is that I solved a lot of them apparently. right? So if I skipped easy problems, I wouldn't be so good at them. Though generally I think if for you struggle only with 5th and 6th problem of the contest, then maybe you shouldn't prioritize Division 3 so much. Shouldn't Division 2 be better for you, where A and B are easy for you and then C and D are a challenge? Basically, the answer to this question is you're practicing different skill going through the easy problems, and whether you want to do it or not, that doesn't matter too much. If you want to be better at problem solving, you can jump immediately to EF. If you want to be fast and you want to practice implementation, you can try the easy problems. I don't know what you prioritize. For example, in ICPC, the team competition, implementation speed is important. So for that, you need to be good at easy problems, also so you'd be faster at using the computer. Also, I think people use virtual participation too much. I'm not a huge fan. A little bit of it is fine. I'm still so angry at that Windows input volume setting. How could it change from yesterday? It changed from 80 to 20. And my microphone and voice level is very important to me because this is my work. Already since the last stream, I also did some other work, like I used Google Meet or something similar to talk with people, to talk with a student of mine, with some one-on-one classes. And now I have no idea if I was very low for them in terms of my voice. They did not complain, but so annoying. Why cannot software just work and not change? When is next AdCoder stream? I think next week. For the next week I have IOI camp, so I will not do AdCoder within the next week. That's what I can tell you. ICPC problem ratings. Why do you need problem ratings? Yeah, Kaneki, then solve C. Apparently you need that more. If you solve AB under 2 minutes, they are not hard for you. Red, and I don't even know what you're asking about. Okay, let's solve the hard problem. How many hours you need to reach red? I think you need years, not hours. You cannot just spend 1,000 hours straight and become red. I think around 20 years are needed, including a lot of math classes in school. I don't know how to measure years. Let me ask you this question, but something reasonable. How many hours are needed to become professional level at football? And for that, are you going to just count the time somebody spent practicing football? Or is it also, you know, physical development when they are young and practicing how to run? I spent way more than 10,000 hours, by the way. Especially if you include math. And for me, I wouldn't be good at programming if not for math. What ranges are asked in regionals? Oh, I see, Redden. You're asking about difficulty of problems in ICPC. Well, from easy to very hard. From Division 2A to Division 1F. So from rating 800 to rating 3,500. Easy. Yeah, I did Math Olympiads. Volcanic eruptions. There is undirected tree with root 1. where every vertex has a weight 1, -1. Okay, vertex, not edge. I've read this problem before, but I didn't remember that it was a vertex. Volcano erupts at time 0 in the root. At time t, lava floods. How do you read it? Floods? Floods? Flood, right? All vertices whose distance from the root is at most t, so it moves 1 unit at a time.
Floods.
Floods. How can you read double O as A? As A? Okay, so it starts from the root, moves 1 edge at a time, and it kills everything. At time 0, you are at some starting vertex, and initially, with life value S, initially you have 1 health point. Starting at time 0, the following events happen in order at each timestamp. So every minute or every second this happens. Your value increases by the weight of the current node, so you gain 1 health point or lose 1. If your health point is 0 or lava reaches you, you die, and then you need to move to adjacent vertex. Find the maximum number of moves you can make before you die. So how long can you survive? Will I participate in Meta Hacker Cup? Yeah, sure. Ramsey is asking how important is the strategy. How do I measure it? How can I possibly know the answer? I don't know. Strategy helps, but you shouldn't spend time on strategy and think about it for more than 10% of the time that you're practicing. I have my advice for how to practice. On Twitch, the link should work. Yeah, this thing. You can go to Twitch to click the link. And go follow that, and that's it. Okay. I think it's very important that the initial life is 1. Also, is there a wrong? Useless wrong. I think that in this problem so there is a tree, there is lava that starts here and kills layers of the tree one by one. Okay, so there is lava. I start somewhere and my health points is equal to 1. If I am in a node where the weight is -1, I lose immediately. If not, then I need to be at a node where the weight is +1. And then if there is neighboring node where there is also a +1, I can keep moving between them to gain a lot of health. The alternative is that next to me there is a -1 where I go, and then just like initially the logic is, after that I need to go to +1, possibly this node itself, but usually not. So then I go to a +1, and always I barely survive. So initially the sequence of moves will be that I will gain +1 health point in the starting node, then -1, +1, -1, and so on. Eventually I might reach a place where there are 2 neighboring +1s that I will keep jumping between them to gain not infinite but almost infinite health. I can do it as long as the lava doesn't reach me. And let's consider the following strategy. That I find some place where 2 neighboring +1s, I go there, I can go there only if the path so far consists of +1, -1. If 2 consecutive +1s earlier, then it's enough for me to get there, and I don't need to reach here to start jumping between them. If there are 2 consecutive -1s, then I will die here, because my initial health is 1. So I cannot afford this. I here always barely survive. -1, -1 would kill me. So there might be such a path of +, then 2 consecutive pluses. And consider a strategy where what I do is I start from here, I go +1, -1, +1, -1, and so on. Eventually you have those 2 nodes with +1, +1, keep jumping, and you keep jumping as long as the lava doesn't reach you. Once the lava would kill you in your next step, you start running away, and your speed is the same as the speed of lava. So you keep going down, and the lava keeps following you. You are always like 1 or maybe 2 steps ahead of lava. Whether it's 1 or 2 depends on the parity. So your initial distance from the lava, I think its parity cannot change, because always lava gets down by 1 and you get down by 1 or up by 1. And if indeed it's optimal for you to be here at +1, +1 and run away like that, you should run away to the deepest leaf below. To the leaf below with biggest depth. But can you die earlier? What if we have a lot of -1s? Then instead maybe you should go somewhere else. Your distance from the root, it decides how much time you had to gain a +1, +1. And I wanted to say that we are iterating this place. Okay, maybe instead we will iterate the endpoint. We will iterate where we will get before dying, and that might be a node that just is a sequence of few -1s. Or maybe for every node I will decide if I can get there, and if so, how late. So how much health points I can get. Okay, something like that. But there is one more thing that I can do first. Before I start running from lava down, I think we can still go up a little bit and then to the side to some deep leaf. Consider a situation. So I think the general case will be that I start here, I go up a little bit and I go down. I find a place with 2 consecutive +1, +1, +1. The lava starts from the root and keeps going down. It's layer by layer. Then from those, and before that what I had is +, -, +, -. Then after this, maybe below this +1, +1, the tree is not very deep. Or maybe it has a lot of -1s. Wait, it doesn't hurt that the tree is not deep here, because I could just longer go here. No, it's important when the lava gets there. So basically it's important when the lava gets to a leaf. Maybe I will not be limited by my health points, I will be limited by just the speed of lava. So it's very likely that the answer is just the distance for lava to get to the leaf, if I had enough health points for that. But what I can also do is, as this last phase, I can from the +1, +1 go up a little bit and then to the side and down, like this, or even like that. I can go above the previous LCA. So this was first phase. Second phase, let's say jumping between +1, +1, and then go up a little bit, then to the side and down. And then the question is how much you can survive. Here I think we will never keep going back and forth between 2 nodes, because it would be better to spend that time here. And it doesn't change anything in terms of lava catching me up or not. If I have spare time to do this, then it means that lava is at this point at least 2 units above me. So it was the case for all this path. So lemma, I will go back and forth only for a single edge ever. So there is some edge, usually between 2 plus 1s. Only between 2 plus 1s, otherwise health points would drop to 0. Lemma. Lemma. There, in optimal solution, there is only one edge of +1 where I will go back and forth. Yes, there might be multiple optimal +1s, that's true. I claim this. If there exists an optimal path, exists an optimal strategy where there is only one edge that I will use. So from this, the solution or idea for a solution is for every edge +1 in the tree, we need to consider this one to be repeatable, and nothing else will be repeatable. For every edge I consider that, and I take the maximum among possibilities. What if there isn't any +1? Then that's easy, because it's just about, it's then just DFS, let's say, how far I can go. Always I know where I am, where lava is, and that's it. So the case without 2 consecutive +1 is so easy that I will leave it for the end. Generally, I prefer to handle edge cases at the end. I'm thinking about the hardest case, about the hardest possible strategy, so what the solution will need to include anyway. And then after that solution is formulated, I will think if I need separate code or separate logic for more basic cases. I'm not familiar with CTFs. I'm not really good at stuff other than algorithms inside of computer science. Okay, back to this. Also, I will type the problem name. I wonder if in OBS I would have a nice way to like take this and put it to always make it visible. I mean, I tried to display the problem statement on the screen so that people who join the stream would know what's going on, they can read the statement. For a hard problem, if somebody is joining, then they will be lost anyway, but at least to display the problem title. This, I think, is a useful information, because you see the contest with the letter also tells you the difficulty roughly, if you know what Codeforces is. You can search for the problem name. Of course, I could also just put text on the screen, but this seems more meaningful because you immediately recognize, oh, Codeforces. Why do you have problem tags on? Because my work is also teaching. So I try not to use them when solving problems, to be surprised. To be honest, so far I didn't look at the problem tags. Now that you asked me, I did look at it. So I see that they're here. But generally I have them on because often I need to find some problems for my students. And when I do that, I need to quickly consider a problem. So when doing that, I will also often look at a problem, and after 1 minute of thinking, look at the editorial to make sure that what I'm thinking about is correct. So teaching and finding problems for students, it's something else than practicing efficiently. All right. So we have this. Now, what should I iterate? I can run the initial DFS only considering jumping between plus and -1 to consider if I'm able to get somewhere. That's the easy part. Then should I iterate this position where I will keep jumping, or should I iterate the endpoint where I will be? So it seems that this first phase is not very important. Just one DFS will handle it. Then we need to think like this. For every such +1/+1 edge, I know after what time I can get there, so this I know where the lava is. And from here, I consider, I don't know how many times I will keep going, but I consider going up and then this way. Maybe I should iterate the LCA. This LCA between the edge that I keep repeating versus then the path that goes down to keep going away from the lava. Hopefully this is such a path that it doesn't have too many -1s because my health points might be not enough. And also its length might be important. If you know where the LCA is, then you know how much time you have for this. Because if from the start you got here at time equal to 7, and this LCA it is at depth, let's say 20, and also there is this distance from LCA to this edge, there is distance of, let's say, 6, then we should combine all this information. Before time 20 you need to get to LCA and start going down. This is distance of 6, so before time 14 you need to be here. So at time, let's say at most 13, you need to from here start going up, which means that this edge you will keep using until time 13. So in this case you would use it most likely 3 times back and forth for the total of 6 turns. Knowing LCA level, you will know how many times to use this. Knowing LCA level and knowing this. So this seems promising. Then from this LCA, we also know our health points. We know that I will get here just before the lava gets here because it isn't beneficial to me to get here earlier. I know that I will now just keep going down and nothing else will happen. I will never go back and forth because I could as well have done it here. So it will usually be the case that I go LCA just before the lava and I keep going down. And I have some health points. Health points are decided by the sum on this path plus the health points excess that I got from going back and forth here, gaining +1 every time. In this case I went here 6 times in total. I traversed the edge, so my health point will be increased by 6 plus the sum of values on this path. Then from the LCA I can, I think, ask this subtree for what is the deepest node such that the sum on the path from LCA to U doesn't exceed something. My health points define that. I will write down this query given the, well, LCA, let's call this node A, and health points H, find the deepest node in subtree of A such that sum of path from A to this node is, let's say, at least H. At least H or negative H, whatever. Okay. Now it's tricky to ask questions about sum of path from a node to another node. It's better to say that it's from the root. So for that you just need to add or subtract from this query the sum of values from LCA, from this node A, to the root, so that it would turn into this. And now when in a subtree you're looking for deepest thing that has its value, sum of the path from the root, at least something, then this value is just one value assigned to every node in the tree. Initially I can run DFS from the root to compute sum of the -1 + 1 values from the root to everything. So this becomes, given node A and value H, find the deepest node in subtree of A with value at least H. Okay? Value that was once computed. And this, I usually solve it offline. You can sort such queries by the value H. So the subtree is just a range. It turns into, there is a sequence of values. This is flattened tree. Not sure about the spelling of this word. There are queries LRX in range LR corresponding to the subtree. Find what? The sequence of values actually comes with second type of values. So it's like parallel binary search. This is solvable, but already too difficult. I need to do it in a different way. Maybe we need, instead of LCA, to iterate the final node. For every node, I will decide if I can get there before the lava, and if so, well, basically how late, how long I can survive, or how many health points I can reach in advance. So maybe there should be this middle phase where this edge will tell the LCA. So every node as a possible LCA will get information of how many health points I can have here just before the lava gets me. And then after that, maybe it's not separate queries. It will be single DFS that pushes everything down. No data structures necessary. Yeah, here when I considered this, I considered Euler tour plus segment tree, but still it turned out complicated. Heavy light decomposition works too. Well, depending for what exactly. If you're asking about subtrees, then I don't think HLD is very useful. I mean, there is some duality between paths and subtrees, but still. For what I was doing here, I don't think a simple segment tree can do it. I wanted to do offline, sort queries by this required value, and in this sorted order activate the values or nodes one by one, so that data structure, a segment tree, would always have only things that have value bigger than something. It's like sweep line by time. Creating segment tree for each depth. I see why you would do it. Okay, but let's try to do it without that, if possible. Especially because it's a division 2 problem. I hope that maybe we will solve it with a series of DFSs, and I won't be surprised if it turns out that actually the time complexity is linear. So if for every +1 edge we are able to propagate its possible value up to all the LCAs, so for all the nodes on the path from this guy to the root, they will get updated info where such LCA candidate LCA, it only needs this. Just before lava gets me, I can get here with how many health points. And if we have this, then we can propagate this down. Because in the middle of this process, for example, here, when you spend some time here, you cannot say what is your current state here in the middle without knowing LCA. Because here, if you repeat it back and forth here a little bit, you have actually two parameters that you optimize. You have the current time / distance to the lava, and you have the current health points. And you want to have still a lot of time left, but you want to have a lot of health points. And you cannot possibly do just some DFS or DP where you know here what is the state, because without knowing where LCA is, you don't know how much health points are required to get there, or at what time you want to be here. So it seems only from LCA down you need this. So I'm thinking now about 3 phases to the solution. Phase 1 will be simple DFS from the start, to this way you get to all edges of type +1/+1. Okay, then some magic, but maybe hard. For every such edge, so from such edges, update LCAs above. I don't know yet how to do it. And then run 1 DFS from the top to push LCA values down. For every LCA I know, I just need single information of how much health I can have being here, and I push it down, it will automatically propagate everywhere down. And I know that I am here before the lava, so I don't care about lava anymore. As I take a step down, the lava takes a step down, so it will not catch me. And below I will never go back and forth, so I don't care about the exact distance to lava, because I know that earlier it was better. So this step is easy, this phase. Maybe I will say 3 phases. Now how to do this? I think this will be linear bottom up. Well, DP is maybe a trivial DP, I think. I think that as we go from the bottom, we always know what is the best for us to get here. No, it's not. Maybe this. So from the start, if I go like this, I think if the path should look like this, and this is the LCA, from this LCA, I think what we are interested in is just the closest +1/+1 edge. If there is the +1/+1 here, and another one here, then why would we go all the way down? Remember that before we visit the +1 edge, the only possibility is we go plus, minus, and so on. So all this white path and all this white path, they are same quality. So this from here, I have some information about it. The information is when I get here. Oh yes, this guy only gets information when I get here. And then I know back and forth I can keep going, and how long I will do it, it depends on where the LCA is, because I need to get up to LCA in time before the lava gets here. Now I run bottom-up DP, where for every node I store information about the closest +1 edge down. Oh yeah, so that's then easy. Always for every node you consider it children. Each stores some information about what was the closest one down there, and I grab the closest one. And then for every LCA I just have that information about the closest +1 where I could get there. And here in constant time I compute, then I will be here just before the lava with what health points. Okay, then I think we have an O of n solution. Yes, Glump, the +1 edge is something that we can keep repeating to increase time by 2 and health points by 2, and we'll do it as long as possible, which means I still need to get to somewhere before the lava does, before I start going down into some deep path where I can survive for a long time. Okay. I think I want to see if the editorial also has O of n solution. If not, then it likely means that I messed up. They do not mention. Do they have segment tree? No. Do they have segment tree here? DFS. Q front, is that priority queue or queue? Okay, they also have linear. So I think I have the correct solution, if this is a sequence of such phases. Now, how long will it take me to implement is another question. Why can't you go above the LCA after doing repetitions of that? I think you don't know what LCA is then. I will try every LCA. The path, there is some optimal strategy, and it looks like this. Go from the start to somewhere, keep going back and forth between 2 +1s, then either from here immediately go down to something very deep, or go up a little bit and then start going down. This node, the highest node where you ever was, we call LCA, or you ever were during this blue path, like this. Then this is LCA. In that last phase, so after doing the +1, it's how high you will climb. What I don't like is this parity thing. For me, the problem would be easier to implement if they guaranteed that, for example, initially your distance to the lava is odd, or initially your distance to the lava is empty, what am I saying, even. Otherwise, I will sometimes need to take care of the parity. Yeah. Doing the +1s is to collect a lot of health. Also, we need to make sure that the solution works if we never get to the +1+1. This is a lot to code. I'm not sure if I want to implement it. Test cases, yeah. Let me see. What I wanted to do today is, if I have enough time, then also solve this problem, variables and operations, which by the way, I think is a very nice problem. I also have read it already, and I know most of the solution, and it's very nice. I think it's okay to say that it's a beautiful problem, but maybe I do not want to rush it. I'm thinking now if I want to implement this. By the way, in my ICPC time, so when around the year of 2017, 2018, when I practiced the most and I cared about ICPC, we wanted to be world champions. I would implement annoying problems anyway, because it was important to me. I had motivation. Now my motivation is to practice a little bit to stay in shape and to have fun and to make educational streams. And for staying in shape, it is useful to sometimes implement a tree problem also where we care about parity. But for the other two factors I mentioned, I don't think implementing this is so important and beneficial. We go up to LCA so that we would have other nodes deep there available. Let me draw a tree where something like this makes sense. Let's say that we start here. This is a +1. Then we have a minus. Then we have a plus. Then we have a minus. Then a plus, minus, plus, plus. And there are few things there, let's say. And what else is there? There is here a plus, then maybe a minus, then a minus, a minus, then maybe plus, maybe another plus, maybe minus, and so on. And then maybe this path is very long. What might be optimal here, also depending on what is the distance to the root from this top node, because I didn't draw a full tree, so there is some stuff above. Starting from here, I want to get to the 2 consecutive pluses, those. I want to keep going back and forth to collect some health points, so I could survive possibly a sequence of -1s. Then afterwards, go back here, go there. And why am I doing that? Because if I finish here, the lava will get to me in the time from the start of the process equal to the depth of this node. So if the lava starts at depth 0 and this is depth 20, then I will survive at most 20 turns if I stay here. Also, it might be the case that this path is just very difficult to survive. There's a lot of -1s. Well, this path is not so bad. But instead, after doing just a few of those steps, maybe I want to get here and then go all the way down there to maybe not the very deepest node, but one of the deep nodes, because there's also condition that I need to have enough health points for this part. And to decide how much I here collect health points, for that I actually, if I know where the LCA is, then I know when the lava gets there. For example, I know lava would get here at time equal to, say, 7. Then I want to be here at time 6 or earlier. From that I can compute when I get here, how much time I need for that, so how much time is left to repeat those steps. Okay, the decision is made for me already, because I'm going to eat. Now, I will think if I want to implement it just during next stream, but I doubt it. Tomorrow I was going to do easier problems. We'll see about that. But one day I want to also talk about this hard problem there. So, look, I recommend this problem, this variables and operations. You might want to solve it, and I think within the next week or two I will discuss it during a stream or a video. How the DP will run, understand the logic, but don't know how it will go up again after the repeating +1 +1. For that middle phase, I described that I kind of proved that always for every LCA, the best candidate for the previous +1 +1 is just the closest such edge down. Actually, that's true up to here. Okay, then there is something incorrect about this middle phase. I think there is some details remaining about this phase. Yeah, it's not exactly a dynamic programming problem. It's DFS problem. Okay. So guys, try that variables problem. I think it's nice. Not nice, beautiful. For today, I'm done. On Codeforces, check out my recent announcements. So there is the IOI camp for those who are participating in regional Olympiads, and then my dynamic programming classes in August, in the next month, for the price of €250. Problem is usually not beautiful. Well, I agree, most problems are not. But if I say so, then there is something about it, right? Okay, thank you for watching. Have a good day. See you tomorrow, same time for the easy problems.